With us here is Robert Winkler from Deutsche Telekom and is one of the drivers of the Eclipse LMOS project. Robert is an enterprise and solution architect at Deutsche Telekom, and he is focused on distributed systems, cloud computing, Internet of Things, and conversational AI. Well, he's a solution architect at day and gamer at night. And since it's the day today, right now, we will see that side. So with this said, Robert, you can now take the floor.
Right. So today I want to show you what we're doing at DT and what we open source as Eclipse LMOS. I won't talk about Eclipse LMOS in detail, but I just want to highlight what we're doing also with Web of Things and WebThing protocol in Eclipse LMOS itself. So Ege already told something about me. I'm also a committer of several open source solutions, so Eclipse LMOS and Eclipse ThingWeb now. Things my project just joined several days ago, and also Resilience for J is one of my open source tools. But today I want to talk what we're doing at DT. And at DT, I'm part of an international team which is building the digital assistant at DT, which is running in multiple countries. So not only Germany, but also Austria and Greece and soon other countries. It's a multi-channel solution, so it's integrated into the web, into the app, and also hotline. And soon we also have a direct voice integration into the app. So there are also different kind of challenges to create a digital assistant, since it's also need to be multilingual. And this digital assistant is now created based on large language model based agents. So when we talk about an agent, we are talking about a software system which is currently using LLMs for doing some sort of course, natural language understanding and natural language generation, but also we're using it for reasoning and planning. So our old digital system had huge flows, JSON and YAML flows, which were driving the digital assistant, and it was just too much effort to maintain them. So now we're trying to build a new agentic system where AI or the LLM is basically driving the conversation. And you can give LLMs certain tools. Tools can be functions they can call, like third-party services, for example. And the LLM itself is doing some reasoning process and basically telling us what need to be called. And then we are performing actions, calling tools, and returning data back to the LLM. LLM also has access to some memory, short-term memory. So that means it can store some information about the current conversation, but it also has access to long-term. But as said, I won't dig too deep into the details how we develop agents. I want to talk about the process, our learnings, and where we use, for example, Web of Things. So over time, when we created the digital assistant, we needed to add more and more APIs to it, to retrieve billing information, to retrieve information about the contract, so maybe just FAQ data. How do I cancel my contract? And the more tools we added, the worse the reasoning process was when we used the LLMs. So we needed to split agents into multiple agents, which are more specialized into specific topics. Because when you had like 7 to 15 tools to an agent, the performance was decreasing. So we split now our architecture in some sort of multi-agent architecture, more in a hierarchical approach, like a tree structure, where we have a supervisor agent, which is retrieving a query, then doing some sort of intent classification. I will show you later how it's working in detail, and then deciding which of the agents should handle the call or the query, or maybe even multiple agents. We don't yet allow communication between agents because it's more than difficult to prevent loops. So we are currently testing the hierarchical solution, but which doesn't mean we might test different strategies in the future. And every agent itself has, of course, then access to tools which are mostly APIs to retrieve information, personal information from the customer. And of course, if you think it now further, already at DT, other departments are creating agents, not APIs anymore, which we need to integrate. They're also experimenting with agent technologies, but also other organizations are creating agents. So soon you will have an internet of agents, basically, where you integrate agents into a multi-agent system and not only tools anymore. So the API is natural language and not API calls. But if you go into this direction, many topics will arrive, like how do you discover agent, how are agent described in terms of metadata, who's the vendor of an agent, what is the idea, how can I access it, connectivity, protocols, what kind of protocols are used, how are the agents secured, interoperability, like in Internet of Things is of course also important. What are the data schemes? How can you group agents? Now, if you have such a hierarchical structure, for example, how can you group agents for different tenants? For example, in Germany, in our solution, Germany would be a tenant, Austria is a tenant, and we might want to have different kind of agent groups serving the needs of the customers. Then, of course, versioning and canary rollout. So there are a lot of problems which need to be solved. And with Eclipse LMOS and Eclipse LMOS protocol, we're trying to tackle all of these problems at DT. And we're not trying to reinvent the wheel. We're making use of technologies like Web of Things or the Web Thing protocol, which we're trying to implement. And the Eclipse LMOS protocol now is now looking into the AI domain, and it's now, as I said, applying Web of Things technology to define a discovery specification, an agent description format. We're also making use of a WebSocket subprotocol. As I said, the Web Thing protocol is something which is inspiring for us. We're trying to define a tool description format, so tools which are used by agents. A semantic data model for conversational agents, but maybe future also for other kind of agents so that they're interoperable. Protocol negotiation is an important topic. I will show you this also in a second, why this is the case. And of course, authentication, authorization, and end-to-end decryption. So last time there was also quite interesting talk about the agent network protocol, and they're using the distributed identity protocol, which is also quite interesting. Yeah? So what we're doing now is that whenever we implement an agent or a tool, we can describe the tool with a Web of Things thing description. So we have agent descriptions, we have tool descriptions with slight differences. I will also show in a second how they look in detail. And from a consumer perspective, so for example, the supervisor agent could talk to agents in different protocols, which are specialized for the needs. We also have agents which perform long-running tasks like doing diagnostic for fixed line connectivity, and they're long-running tasks. Then we need more messaging protocols than request reply protocols like HTTP. So we can now use WebSockets for some agents, HTTP for others, and maybe messaging protocols soon for other type of communication patterns. And the consumer can now discover agents which are registered in directories. So tools and agents can register themselves, or just the idea, or also the thing description, and consumers can query the directory to retrieve information about the agents. And how does it look like in Eclipse LMOS right now? So Eclipse LMOS has its roots in the JVM Kotlin ecosystem, so not Python. When we started, the Python open source solutions were not yet enterprise ready. So we started something by our own, but soon I hope we also provide Python SDKs so that we can also make use of Python AI libraries like LangChain. But in our ecosystem, we are currently building. So I need to say Eclipse LMOS, the first release is still ongoing. So it takes some time to migrate our proprietary software from DT to Eclipse open source. So the first release is still ongoing, but we're working on the LMOS Kotlin SDK, so consumers and also servers who are implementing agents can use this SDK, which is based on Eclipse ThingWeb. I can also share the link, but also Ege can share it. So you can now plug in, it's like a plug and play system. You can plug in protocol bindings into consumers and also into agent providers so that the servers can use the protocols to provide the agent on a certain protocol, maybe even multiple in parallel, and consumers can use multiple in parallel. I will also show in a second how this looks in detail. And things and agents have identifiers. For example, you could use a decentralized identifier and even use this to then resolve dynamically where the DIT documents for authentication and verification of the agent are resided. And you can also use it to discover the Web of Things description for agent and tools dynamically, even without a registry if you have access to the ID. And the LMOS Kotlin SDK, how does it look like in detail? So if your background is in JVM, we're using Spring Boot as the base framework. Then we have developed an in-house framework called Arc. So LMOS Arc is a Kotlin framework and is providing a domain-specific language to develop agents. We have developed a framework called Kotlin WT. It's now part of the Eclipse ThingWeb project to serve as a client and server framework, which is extendable by new protocol bindings to enhance other protocols or provide protocols in the future for AMQP or MQTT. And then, of course, we're using OpenTelemetry to send logs, metrics, and traces into some observability solutions. But how does the thing description look like? From our point of view, it contains some agent metadata, so like the identity, some version information, security information, but it's also describing the API of an agent in terms of properties, the state of an agent or tool. It can have actions. How do I communicate with an agent? An agent can also publish events, which then allows also event-driven architectures. And this is one of the extensions of LMOS, which we need at DT. Since the API of agents, like an action, might consume natural language as an input and produce natural language as an output, the API itself does not describe the capabilities of an agent anymore. There's no view builds action or function. There's no view contract action anymore. But from an integrator point of view, the supervisor agent, for example, definitely needs to know the capabilities of agents. So this is how a thing description look like. You have some context information. We have some LMOS specific extensions, for example, new types to differentiate between agents and tools. We might introduce different kind of categories if it's a conversation agent or if it's an agent which is maybe generating images. So over time, similar to smart home IoT domain, there might be different kind of categories or types for different kind of agents and tools. The agents can also have links to additional information, like manuals, but we use links to link to the capability files, which tell you more about the internals of the agents. I will also show how does it look like. And then, of course, you can also add digital metadata. Who's the vendor? Does the agent comply to GDPR compliance requirements and so on? So this is just an example. From a security perspective, Web of Things provides different security schemes like basic auth, BIRA, OAuth2, so it's also extendable. At DT, in order to talk to agents, you need two kind of tokens. One is a machine-to-machine token. You can nicely describe this in Web of Things, and you also need the user token. So it could also show how you could, or a customer can retrieve its access token to give us the permission to retrieve personal information about himself. And then this is an example of states. This is, I said, also just a simple example to describe the capability. So an agent could have a property which tells how the agent is configured, or let's say the LLM is configured, and which LLM is used, how's the temperature configured, can be read-only or even writable properties. And this form section is the most interesting part, which makes Web of Things, the Meta protocol agnostic. From a client perspective, the client is looking into the form and sees, okay, this tool or agent is accessible via one or multiple protocols. And the scheme here, for example, HTTP, then tells the client, okay, I need a HTTP protocol binding to communicate with this agent. And it can also have protocol-specific extension, which tell, okay, you need to do a GET call on this URL to retrieve the property called model configuration. And similar, it works for actions. You can have actions like, for example, it's also a simplified example. In our system, it's looking more complicated. But you can have a simple example here, call an agent with a natural language question. Output is also natural language. And here it's a form, it's a post request on a certain endpoint. Then you can have also events. For example, maybe as part of a conversation, the customer can also rate and give feedback how the conversation went. Is this question, was it solved? And then agents could also publish events, which can be consumed by other systems. And here it's interesting, you could also now use a WebSocket protocol for real-time eventing of events. You could also use the WebSocket for properties and actions, what we are currently doing. And here we're using the LMOS protocol. I said it's heavily inspired by the WebThing protocol. So as soon as the WebThing protocol is ready, we might migrate to it. Right now it's still called LMOS protocol. So this is the application level protocol to send messages to the agents so that they understood that it's here maybe a subscription to events or unsubscribe action. So it's quite complicated. And if you're familiar with Spring Boot or in the JVM ecosystem, you usually just write classes with functions and then you annotate them. For example, with additional information, like this is an action, you can give descriptions to the input and output, or this is an event, you annotate it with an event. And since it's a flow, it's a stream, a reactive stream of events. And as a developer, I don't care if it's WebSocket or MQTT or AMQP. This is handled by the framework. So even the thing description is automatically generated by the framework. You don't need to maintain it by your hand. You basically, it's like code first, and then the API is generated. And from the client perspective, with the SDKs, you can create some sort of Web of Things conversion agent. You point it to the Web of Thing description, or maybe even to a directory. I will show you in a second how it could look like if you point it to a directory. And then it could potentially discover all things or agents which are stored in this directory. And then you can start communicating with this agent. You can consume events, or you can subscribe to events and handle them, and even then call other agents. Or you can chat with an agent or do other things in the future if it's an image generating agent. And from the code perspective here, everything is asynchronous in Kotlin. So it could also be a WebSocket connection. As a developer, you basically don't see it. You only have to add some additional libraries like the protocol bindings I was talking about, like HTTP and WebSocket. And then the framework is wiring everything for you. And at runtime, the client is doing the protocol negotiation. It's telling, yeah, I support WebSocket. Let's communicate via WebSockets. And before I show the Elmos platform itself, I just want to show you, so Eclipse Elmos, there's a documentation if you're interested in more details. This is the documentation of Eclipse ThingMap. So these are the underlying libraries which we're using for the SDKs. Hopefully soon we also have a Python library. And now I want to show you an example which is based on WebThings. WebThings is also a nice project which is providing a gateway which you can use to connect smart home devices to it. And here, for example, thanks to when I have access to a plugfest gateway where a lot of virtual devices are connected to. And I just tested it to connect to this directory to retrieve all the things and automatically convert them into tools which then can be called by an agent. No? So when you query, for example, the directory URL of a directory, what you get is also a sort of thing description. Which is describing how you can retrieve all the things. So things themselves are just property or the state of a directory. And if the client is then querying automatically the things, it's getting an array of all the devices here which are described. For example, it's an on-off switch or color control and all the properties like how do you turn a device on. And this is not dynamically converted to functions LLM are understanding. So LLMs can also understand what is a function, get a description and the input as JSON schema. And without adding any specific smart home functionality, I just really converted to tools which the LLM is then getting. I can ask a question, even if it's a multi-intent question, like set all my color lights to green and afterwards turn on all the lights. You will see it's not working perfectly, but it's just basically without doing anything. I point this to my agent. The agent is reading all the things from the directory, and you can see now it's turning all lights red and then afterwards turning the lights on. And this just by using the descriptions of the devices, which are then converted into LLM functions. So quite powerful. And I mean, if you really spend time into it, you can quickly do something which was much more complicated when you had to develop skills for Amazon Alexa or Google Home. And this is the Elmos platform, which we also made open source. So whenever you deploy now an agent or a tool as a microservice or into a Kubernetes environment, we have added something which we call the Elmos control plane. So additional components which are tightly integrated into Kubernetes. So the Elmos operator is now doing the lifecycle management. So whenever an application installed, it is notified and is then fetching the thing descriptions of the applications and basically storing in our Kubernetes registry. So the Kubernetes registry is currently used as the storage mechanism, and the operator itself is also providing the directory API from Web of Things so that you can discover which agents are currently installed in the Kubernetes environment. And it's also our goal that we can even include external agents which are not running in our own Kubernetes environment. We can fetch the thing description running anywhere, but still maintain them and include them into our agent groups. And hopefully soon we have an Elmos Python SDK where you can even develop agents in Python and LangChain. And as said, agents are providing additionally the capability. So capability has also identifier a name, a versioning, and a description, and examples. And this is what a agent is capable of internally. Yeah? So if I have integrated APIs which allow me to retrieve billing information about the customer, the agent is providing this information in additional JSON file. This is a really simple example of a single capability, but this file is linked in the thing description, so the operator can fetch the capabilities of the agent, which is also providing examples of customer queries, so example utterances, and it's using it now. And additionally, we have now implemented something which we call channel management. This is like a dynamic grouping of agents. So we have different channels like web and app and voice, and we want to do canary rollout. So not publish agent capabilities on a single big bang to all channels. We want to test certain functionality only on a subset of the customers. So we are inspired by something which is called the requirements capability model from OSGI. So a channel can require certain capabilities, and then the operator is acting as a resolver and checking, is there any agent installed in the Kubernetes environment which is providing me the capabilities? It's like a dependency manager with libraries. And then it's telling you if the group is resolved or not, if you need to do something or install other agents. And then it's basically generating, I will show this here. So as said, the operator is listening for deployments and then installing them in the registry as a new custom resource in Kubernetes, which is an agent resource. And when I now a kube applies, or when I apply a channel, it's now loading all information about the agent, and it's generating a channel routing, which is basically like a routing information, like a usual router would use. But now we need to do routing based on natural language. We cannot use Istio or Kubernetes anymore to do smart routing decisions. We need to do routing on intent classification, on natural language intent classification level. This is how a channel definition looks like. So basically, I define what kind of requirements I need. You can also use wildcards, and then the resolver is generating this channel routing and tells us, hey, I've discovered certain capabilities. So these are the capabilities which I've discovered, and also telling us what is the agent, so the agent identifier, which is providing the capabilities, so that the component, so the supervisor who is doing the orchestration knows for which agent identities I need to fetch the thing description in order to understand how I can communicate with this agent. So when a query comes in, the supervisor is doing some pre-processing, anonymization, for example, something which is important, and then fetching the channel routing information from the operator for this conversation. Then it's caching it, providing to a component which is called the LMOS router. And the LMOS router is currently using LLMs and soon also vector databases to understand the intent of the customer. It's providing the capabilities which are currently enabled for a certain channel. And in this example, it's the web channel. Then it's checking, is it an alpha customer or just usual production customer? Then based on the question, it's generating a subset of the capabilities, which somehow kind to match the intent of the customer. And then the subset of the capabilities is provided to an LLM to do the routing decision, which of the agents seem to be able to handle the problem of the customer. And then the runtime is communicating with currently just a single agent, but soon we will also allow in parallel communication to multiple agents and then aggregate the responses back. So I also want to show you how does it look like. So for example, here we have a system, Kubernetes system. As you can see, only a weather agent is installed, which can tell you what is the weather in a certain area, and then the operator and the runtime is installed. The runtime is also a library. Here, it acts as a supervisor. You can see that agents are now a native resource of Kubernetes. I can query which agents are installed and can also get additional information about the agent. I can see which channels are currently installed in the system. So here it's just a channel for Germany. It's an app, and it's the stable channel, which is used for all production users. And when I, for example, ask how's the weather in London, it can answer you. No? But when I ask a different question, for example, summarize me the content of a certain web page, it says, I cannot help you because the capability is currently not provided. In production, we would usually hand over the customer now to the service hotline, and it looks nicer. This is just a test UI, of course. But now I could basically reinstall a different agent as a Helm chart, so as a Kubernetes environment. Now the operator is fetching the capabilities of the agent. And now when I apply now, let's say a new channel configuration, which now says, now I also want to use the capabilities of the new agent. It's now generating a new, you can see now, it says it's resolved. So all capabilities are found in the system. I can ask agents, both agents seem to be installed. Now, yeah, usually as soon as the application is running, the router is able to route now questions to this new agent. So when I now repeat my question, you can see now the system is able to respond to it. And this is basically now the dynamic system which we need at production, that we, whenever we need, can install additional agents into the system and roll it out to a certain customer base. And as I said, in our system, it's a bit more complex. So the message itself, of course, is not just the question. We also, clients also can provide us additional information about the user. So we call it user context. The touch point already knows. Maybe it's a B2B customer, B2C customer. Is it just a mobile customer? It can also already provide the information to us, or maybe the customer identifier. But systems can also provide system context information. So now we are in a multi-channel environment. So web can render nice UI widgets, but in the hotline, of course, cannot render UI widgets, and it might need shorter answers, and links can also not be presented. And WhatsApp has even different requirements, cannot render Markdown, for example. So the touch points can send us additional information, what kind of technical capabilities they have, so that our agent can also generate the responses, how the touch point is requiring it. So the supervisor agent is then getting a system prompt and telling it how to act. It's getting information about the user, about the system, what kind of capabilities are currently available for this channel, then the conversation history. Then the supervisor is doing the decision, picking multiple agents and forwarding the information to the agent. So also the agent has information about the user and system context and the conversation history. And then the agents have all the use cases implemented, like flows. Use cases are not prompts, they are more like workflow descriptions. So if you're asking Bill, of course, the agent does not know what you mean. He might ask you and query, first of all, what kind of contracts do you have, and then ask the customer, do you mean your mobile contract bills or your fixed line bills, from which year? So it's the use case is basically described like in handbook, how the agent should behave to retrieve additional information, to not overfetch data, and just fetch the information which is needed to solve the customer query. Yeah, so that's basically a very, very quick introduction. So I hope we have more time to for question and answers. So we have also a Discord channel. Feel free to join. We just started. So last year, maybe September, October, we started making everything public, open source. So I think the solution is still a bit edgy. is actually has a lot of corners. So we are still working on the release, but I hope you find it interesting.